So today we're going to be covering flat roof diagnostics, and hopefully you'll be able to take something from this. And within the presentation, we'll be covering surveying a roof, the purpose of the survey and how to go about this in a logical manner, the investigative side of a survey and producing a report, moisture mapping and how this works, the advantages of moisture mapping, and then we'll go through a case study to finish off with. So what is the purpose of the survey? The purpose of the survey is to provide information on the existing structural deck and its condition, whether the deck is fragile or has been damaged and needs to be considered as fragile. Core samples will confirm the existing waterproofing system build-up and its condition. And taking more than one core sample can confirm if the falls are in the structure or in the insulation, an important factor when considering the options moving forwards. Defects on the roof and areas of degradation, and trying to highlight the amount of moisture present at this stage is quite difficult when you are only cutting a couple of small sample areas. And if possible, what is causing or where is the sort of source of water ingress coming from? So when conducting the survey, it is also important to try and establish the following. Is there a potential for an overlay? Is the roof suitable to overlay? The potential to convert a cold roof to warm or inverted even, as cold roofs are difficult to ventilate adequately, so a warm or inverted option keeps the detailing a lot simpler. That the existing waterproofing is adequately attached to the deck. This is key to ensuring the roof will stay in place beyond the duration of the system guarantee offer, and whether removal of the waterproofing would be detrimental to the existing deck. So if you have a fragile deck, this is certainly a huge consideration to take into account, as removing the waterproofing may cause damage to an already fragile deck. Check the ceiling void for additional insulation present, and if you are changing from a cold to warm roof, then consideration needs to be taken in regards to removing the existing insulation. Evidence of ventilation present or condensation issues. When there is ventilation and you're upgrading the insulation, then blocking the ventilation is a must for the roof to perform correctly. And recording any related issues that might impact any refurbishment must also be carried out. When carrying out a roof survey, it's also important to take a look internally before carrying out the survey. This can give you some indication of the deck type and may highlight areas of water ingress that have already occurred, although access to the underside of the deck is not always possible. It makes perfect sense to follow a logical process of identifying the factors listed in this slide in order to ensure nothing is missed and to give you all of the information you need to put a report together for your client. The purpose of the survey is to confirm your findings and recommendations, and confirmation of this is usually provided by means of a survey report. When taking core samples, it is important to take the core samples at the point where we are most likely to find moisture within the construction. We use the internal and external inspections to inform this decision, and also the position of any existing internal outlets. We identify the layers within the waterproofing build-up, also confirming deck type. Multiple core samples may be taken on a roof area to establish the consistency of the construction and condition. We want to ensure our findings are analysed and recorded with photographic evidence. And finally, ensuring our sample is replaced and sealed upon completion. From the information taken on the roof, we can construct our survey report and specification if required at this stage. Here you can see a typical Bauder report. The report will contain a roof plan and images of the roof and also the core samples taken. This will be based on our findings, and within the report we will also include our recommendations moving forward. The results of the core sample, in addition to the client brief, will then identify the most suitable course of action. On this slide, on the left, you have the different scenarios where a full strip of the roof would be required. As you can see, it isn't just a wet core sample which can lead to stripping off the roof being the most suitable action. The core samples could be dry, but the waterproofing is in such a poor condition that is not suitable to be overlaid or left down. Alternatively, the roof may have been overlaid multiple times, and to add an additional roofing system could add too much weight for the roof structure to take. On the right-hand side of this diagram, you can see the requirements for an overlay. In general, each of these elements must be met. Worth noting, a fragile deck can be a reason for both strip off and overlay. In the correct scenario, where the roof is in a good condition and the construction is suitable for an overlay of the roof, this may speed up works on site, minimize internal disruption, save costs, and make the refurbishment safer. For example, in some scenarios, overlaying a wood wall deck roof with a layer of plywood and then the new waterproofing system ticks all these boxes. Then there are some scenarios which fall between these two images shown. In these situations, further investigation is required. When you're maintaining or upgrading buildings, your clients are constantly trying to make the smartest investment. This presents surveyors with the challenge of delivering predictable project costs and providing precise technical data to enable clients to make the correct decision. So what do Bauder use? Bauder uses a Troxler 3216 roof reader for moisture mapping the roof. The radioactive source within the gauge is designated a special form, requiring it to have passed rigorous safety tests prior to certification. This testing demonstrates the strength and integrity of the capsule that is contained within the source. The radiations from the instrument do not result in any damage to the roof, nor do they result in any object becoming radioactive. The gauge is lightweight and easy to handle, with a button on top of the handle to enable a digital reading to be taken. The reading on the gauge is indicated in two ways. One in the form of a needle, which is close to the handle on the image. This gives you an instant indication of the reading expected if you were to place it directly onto the roof surface without pressing the button. The other is a digital display, which is activated when pressing the button on top of the handle, and this gives you an exacting reading when utilized. So what are the benefits of moisture mapping? The benefits of using the moisture mapping survey are being able to identify areas of moisture within the existing original build-up, backed up by core samples confirming the readings. After completing the roof survey, Bauder would be able to recommend which areas need stripping and which areas can be overlaid, if there are any, rather than assuming the whole roof contains moisture if a wet core sample is found. Using moisture mapping gives the client an exact brief on their roof, which can lead to a peace of mind and possible substantial cost savings on the project. The moisture gauge also gives pinpoint data readings, which are exacting rather than open to interpretation in regards to a person's opinion on color imagery provided by thermography images and survey. Bauder's moisture map can verify the specific levels and locations of moisture within an existing waterproofing system. From this testing method, the true condition of the roof is identified, plotted, and a visual data report produced that determines the remedial action required. This appraisal is a scientific survey which provides explicit data on the roof's actual condition. Core samples are taken to confirm the data provided by the moisture mapping gauge, and the next slides I'm going to show you are animated, and this will indicate how the gauge works. The source itself, when activated, emits fast neutrons. When there is no moisture present within the buildup, these are not slowed down by the material being dry, so there's no hydrogen contained within the system. So what this would do is this would give you a lower reading on the gauge. When there is some moisture present within the buildup, the neutrons are slowed down by the material being damp, so small amounts of hydrogen contained within the system. What this would then do is give a higher reading than the previous dry reading on the gauge. When there is a lot of moisture present within the buildup, the neutrons are slowed down even further by the material being wet or possibly saturated, so large amounts of hydrogen contained within the system. This would give us a higher reading than the previous damp reading would have given on the gauge. I will touch on how these readings are captured and documented during the process of moisture mapping. So when further investigation is required to get a better picture of the roof condition, a moisture map survey can be conducted. Moisture mapping surveys are best suited where the roof is over 200 square meters, and the best results are achieved when you have a build-up where the construction includes insulation, so a warm roof build-up. Results of surveys on uninsulated roofs can be unreliable and should be used as a last resort, and the results taken with caution. The surface of the roof needs to be fairly even to achieve the best results for maximum surface contact of the gauge, as trying to carry out a survey with a roof covered in stone ballast would be difficult to get true readings, as the gauge would only be making contact with a small percentage of ballast and the build-up would also be inconsistent. If there are large areas of ponding water, this would be impossible to take readings as the gauge is not waterproof. But the process itself is fairly straightforward, as can be seen in this slide. And there will always be questions when someone is using a gauge like this one, so we will always explain how we will carry out the survey prior to commencement of the survey. Once we have carried out the process prior to survey, the last thing we do before the survey is to mark out the roof with marker cones, usually at 2 meter centers. This can be adapted for smaller roofs, or if you are specifically wanting to pinpoint areas of saturation or even dry areas of the system, then these grids can be smaller. As you can see on this image, the marker cones are spaced evenly, 2 meters apart. This has nothing to do with COVID. It's just the reference readings that we take on the roof. And this enables us to take a reading and start to plot the roof onto a plan. The roof surface shown in this image is a felt build-up, but the gauge can also be used on a variety of waterproofing finishes. From here, we start to take grid reference readings to build a roof plan as we map with the readings taken. Where there are obstacles on the roof, such as plant, roof lights or standing water, these will be marked on the plan with letters rather than gauge reading numbers to highlight where they are, as no readings will be taken at these points. As I touched on earlier, neutrons are emitted from the gauge and are slowed as they interact with hydrogen. The more hydrogen present, the higher the reading. The level of hydrogen correlates with the level of moisture within the roof construction, although other materials also have hydrogen content, so this has to be taken into context. Because of this, every moisture map will include core samples, which are used to calibrate and also verify the readings that are given. The readings are then converted into a histogram, which gives you a literal map of where the moisture is or is not present within the roof construction. And as can see here, here's a histogram, and the arrow shown indicates grey being dry and red being saturated. Anything else in between red and grey will have varying amounts of moisture contained within. Bauder will have always carried out an initial survey prior to the moisture mapping, which will have given us a picture of the roof build-up through the core samples that we took in the initial survey. When we're moisture mapping, it is important to take the core sample at the point where we are most likely to find moisture within the construction. This will be based on the readings taken. Multiple core samples will be taken on a roof area to establish the consistency of the construction and its condition. The core samples will also help us to verify our readings and also our findings. Here we have an example where we could offer a full overlay, as this will have little or no water saturation. The existing construction on this roof included a metal deck, polythene vapor control layer, PIR insulation and a single ply membrane. This buildup usually has very little hydrogen within the material construction. Consequently, the range of readings is quite narrow, as you can see on the image here, shown here between 8 and 22, with a reading of 14 and over representing wet areas. On roofs such as this, where 95% of the roof is dry, it can be overlaid with very little preparation. The area of wet roof construction can be pinpointed and removed. Here we have an example of a partial overlay, so 25 to 40% of the roof area found to contain high levels of moisture. This project has a much higher range of readings. In this example, the existing roof construction includes bituminous membranes and insulation over a screeded concrete deck. When dry, this construction contains a higher level of hydrogen than the previous example shown. So we would expect readings of 27 and under to be dry. This is represented by all the grey areas on the graph here. Wet readings were between 27 and 88 and range in colour from light blue to red. Where isolated areas of a roof are found to be wet, as in this example, they can be pinpointed and cut out, removing the wet roof construction. These areas can then be infilled with an appropriate thickness of insulation and made watertight. The whole roof area can then be overlaid with a new system. Existing wet areas of roof buildup need to be removed as it can result in leaks into and damage to the building, contamination of the new roofing system, and potentially failure of the new waterproofing system. Using the moisture map to pinpoint and remove wet areas allows the roof to be overlaid without risk, which saves money and time and also reduces disruption to the occupants of the building. Here we have an example of a roof requiring replacement where more than 40% of the roof is saturated. On this project, the range of readings was larger again, going from 30 all the way up to 160. On this project, dry readings were 40 and under, so grey images on the imagery, with everything over 40 containing a level of moisture, so anything blue to red. When approximately 40% of or more of a roof area has a level of moisture within it, surgically removing and infilling that 40% becomes uneconomical and costs more time and money than it saves. In situations such as this, there is only one option, and that is to remove the existing roof construction back to the deck and start again. Once we have all of the data, we can put together a detailed survey report with more accurate information as to which areas of the roof have problems with water ingress. The data provided will give a true indication of what is occurring on a specific roof area. This will enable a clear, defined definition of what needs to be done to specific areas of the roof. This could possibly save a lot of money in regards to not having to remove areas of roof that are not contaminated with moisture. Here we have a case study, and here we can see a photo of the original roof prior to us carrying out a roof survey. And the client's brief on this was to carry out a survey to determine the best course of action with minimal disruption. From this, the original survey report was sent to the client. This included the roof plan and supporting information. The roof was approximately 12,200 square meters, and by taking a couple of core samples gave us an indication of the roof build-up, but on a roof of this size they are minimalistic as to what is actually happening on the rest of this roof. So following the initial survey, the client's brief was also not to have any disruption to the manufacturing facility, as works inside needed to continue despite the need for external roofing works. A decision was taken to carry out a moisture mapping survey to see if we could overlay as much as possible, so dry areas, to cut costs and minimise disruption to the internal production. When we planned the moisture map, we split the roof into 4 sections, so we were able to show this on a detailed plan, as trying to plot this size of roof onto one plan would be impossible to show in a report. On this slide, you can see the figures taken on the left, with a single red reading where a core sample was taken. Alongside this is the section of the roof. These figures were used to plot the graph. with the red area highlighting an area of moisture and grey areas being dry. A total of 1,125 readings were taken for the whole of the roof, highlighting approximately 5% of the roof to contain areas of moisture. So from the moisture map and core samples, this meant the contractor could strip exacting areas of moisture contaminated buildup and overlay the areas which were not contaminated. And here you can see an image of the finished roof. This partial strip allowed for a quick and undisruptive installation, which is very important to the client as they wanted the production to remain fully operational throughout. Despite the challenges faced on this project, the moisture mapping enabled the project to be completed on time and to budget, ensuring the client's brief was followed through to completion.